So for our last part of chapter 43, we're going to go through some of the major orders of mammals, and we'll also talk a little bit about the zoology of humans, because we're included as mammals as well. So for this first slide, like I said, we're just going to go through some of the orders of mammals. We'll get to know some of their names and some of the organisms that are included in each order. The first order we're looking at here is order Xenartha, and this includes some of the animals you know as anteaters, armadillos, and sloths. So remember, when things are placed into an order together, that shows that they are very closely related. So, for example, the anteaters, armadillos, and sloths, they're more closely related to each other than they are to other mammals. And these are always going to be based off of a few pieces of evidence. Most of the time, we're looking at things like their physical characteristics, their DNA, and then sometimes fossil evidence to kind of place these things, close together if they're related. Order Lagomorpha includes rabbits, hares, and pikas. Pikas are sort of like little rodent-looking like rabbits that are found in this order as well. So once again, all of these guys are closely related to each other. Lots of similarities between them, and rabbits they're found a lot throughout North America and other places too, even down in like Australia. So these types of organisms are found kind of spread out all over the place. Order Rodentia, or Rodentia, as some might say, includes everything we think about as being a rodent. We use that term a lot. So, of course, your mice and rats are here, but also squirrels, marmots, chipmunks, gophers, even the porcupine is included here. So, there's lots of diversity in this group. Some are big, some are small. Some of these are pretty unique. The thing about rodents is they have two very large front teeth. So that's something that all rodents are going to have when you look at their teeth. And that's actually how you identify rodents. If you come across a skeleton of them, the first thing that someone would look at would be their teeth. If they have two very large front teeth compared to everything else, these are going to be included in the rodent order. Order of primates includes many different organisms, including lemurs, tarsiers, loriers, monkeys, gibbons, apes, and humans. So anything that you think of as related to apes, monkeys, lemurs, these are all going to be in the order primates. The thing about these guys is they have an ability and adaptations to move through trees, a lot of them, and some of them, well, humans have bipedal motion, meaning we walk on 2 feet, but most of them are going to be walking on 4 feet, hands and feet, I should say, for some of their time if they are on land. But like I said, many of these are going to be adapted for moving and swinging through the trees. That's sort of one of the big things that this order of mammals is really good at doing. One of the more interesting, in my opinion, orders of mammals include Chiroptera, and this is because this includes the only mammals that can truly fly. So all of your bats are going to be here. I just had a bat in my house in the fall. Had to chase it out. My cats heard it doing that high-pitched echolocation sound that they do. Sounded very scary when I didn't know what it was at first. But the cats got on it, and luckily I was able to help the bat escape. I'm not about, slaughtering bats in my house. I wanted to make sure my cats didn't, bite it in case the bat was carrying something, like some type of disease or something that the cats might be able to get. So I was very careful with using a broom to get the bat out of the house without injuring it too much. But yeah, this is the order of mammals that can fly, and we'll take a look at a example of how we think bats got this ability to fly in a video assignment you'll have later on. Order Insectivora includes organisms that feed primarily on insects. They're insectivores. Some of the big organisms you might know in this group include things like moles, shrews, and hedgehogs. So they're adapted for eating mostly insects, this group. Order Carnivora includes your main carnivores, things that are going to be eating meat, other bigger animals. So this includes dogs and cats. If they're out in the wild, they're eating mostly meat. I know that we feed a lot of us feed dogs and cats kibble, which has corn and stuff mixed into there, but actually, dogs and cats are categorized as carnivores. Meat is an important part of their diet. They need a certain amount of protein, and they're well adapted for eating meat with their sharp teeth. Raccoons, bears, hyenas, otters, seals, and sea lions. These are going to be all included in the order Carnivora. Order Artiodactyla. This means having an even number of toes. So in this group, scientists have placed things that have an even number of toes. Things like deer, cattle, giraffes, pigs, and camels. These are all included in the order Artiodactyla. So most of them have 2 toes, some of them might have 4, but they have an even number of toes on each foot. Order Perissodactyla. This includes organisms that have an odd number of toes on each foot. Even if it's just 1 toe on their foot, that's an odd number. So horses, zebras, a rhino, tapirs, which is that weird looking organism over towards the bottom right. These are all going to be in the order Perissodactyla. So this is something that scientists have based this order off of. As you can see, a lot of these orders are based off of different physical characteristics. It's just a way for scientists to try to make sense of the world around us and give us a way to categorize organisms. So since all of these organisms have odd number of toes, scientists look at that and look at their genes and they think that these organisms are more closely related to each other than they are to other mammals. Order Cetacea includes whales, dolphins, and porpoises. So these are some of the major mammals of the sea. This group is actually, when we look at it, closely related to the order that contains cows. We talked about how ancestors to these mammals once lived on land, and then some selective pressure pushed them to become better at living in water. They have modified nostrils. They have blowholes up towards the top for the most part. It's really a modified nostril they use for breathing. Remember, they have to come up for air. These are not fish. They are mammals, so they have to come up for air. So very, very cool to see that not only do we have most of our mammals living on land, but some of them can fly, and then we have some of them that actually live exclusively in the ocean, even though they have to come up for air. So mammals have really taken over every part of Earth during this time. So this is kind of the age of the mammals that we're living in. Order Sirenia includes the manatees and dugongs. So these are going to be ones that are still kind of, they have adaptations to live in water, but it looks like they evolved to live in water separately from the whales and the dolphins. So they shared a slightly different ancestor in the mammal classification system than the whales and dolphins. So they're not as closely related to whales and dolphins as they are to each other. Order Proboscideae. This includes the elephants, mastodons, and mammoths. So really, today the only surviving members of this order are the elephants. The name Proboscideae, this refers to the very, very long snout, the very, very long nose, if you will, that these organisms have, like we call them a trunk today. But that's something that all of these organisms had, even looking back at the mastodons and the woolly mammoths, that went extinct back in the Ice Age. They all had this feature. So that's something that shows us that these guys must be closely related to each other because this feature is coming from an ancestor that gave rise to these. So that's going to be the order that only today includes the elephants. So we'll wrap up by talking a little bit about primates and how humans come into play with this. Many primate traits are adaptations for living in groups in trees. That's something we've talked about. Many primates have grasping hands and tails and rotating shoulder blades to help them move through trees. They have really good three-dimensional vision, so they can tell, um, the depths of the branches all around them, so they can accurately move through the trees. So that goes into the depth perception too, to show how close or far away certain branches are. So they have these prehensile appendages, hands, feet, and tails that can grasp. Even the tails of most monkeys have sort of a pad or a rough spot on them that help them grab onto trees as they're moving through. So that's something that we see a lot in. Anthropoids are organisms that appear to be ancestors to primates when we look back into our fossil record. So when we look at some of these guys, they're primate-like, so they appear to be like monkeys and apes. Some of the adaptations that they had was a rotating shoulder and elbow joints to help them move and swing through trees. Um, Having an opposable thumb is something that these guys have as well. They have a certain number and arrangement of teeth when we look at these guys. And they have a more complex brain structure and a larger brain relative to size than a lot of other mammals. So when we're looking at these ancestors, we're starting to see some higher thinking come into play. This is going to help them not only move through trees and stuff like that, but maybe start to use tools. The first primates probably resembled modern chimpanzees. So the first animals in the group of primates probably looked similar to today's chimps, not exactly alike, but similar based off the fossils that we have found. So when we look at the primate order, there are a group of organisms called hominids that exist in this order. And actually, we're the only ones that currently exist today. Hominids, these are going to be organisms that resemble humans more than monkeys. So um, being bipedal, having bipedalism, that means that the tendency to walk upright on two legs is something that we use to classify hominids. Now we're, like I said, the only organism in the order primates that walk on two legs today, but there were others that have gone extinct. We know this because we have found fossils for them, and we're able to date them and see how long ago they lived. One of the most famous ones was Lucy. This is going to be a fully preserved fossil that we found that gave us a lot of information about what these look like. One of the early ones was Australopithecines, easy for me to say. This was a group of hominids that lived a long time ago. All of these fossils for this group have been found and discovered in Africa. You might have heard of the organism called Homo habilis. Homo habilis, these were referred to as handy humans because it looks like when we found their fossils, we found a lot of tools in the areas that they lived. So it looks like these are going to be some of the early hominids that first started to use tools for things, maybe such as grinding stones to grind up food, building spears and things to hunt food. And these are going to be the earliest members of the genus Homo, which actually includes us. That's the genus that we are in. So one of the members of this group that is thought to be most closely related to us is Homo erectus. This name means upright human. This organism walked mostly upright and was taller than Homo habilis. And modern humans are probably most closely related to Homo erectus. There are lots of similarities between Homo erectus and us in such as the way that our skull is shaped, similar size. You can see that the Homo erectus skull is kind of flattened out a little bit more up at the top. So modern humans have a little bit bigger brains. Looks like our jaw is a little bit smaller than Homo erectus when you look at maybe the width of it, but similar shape. Looks like their skull was a little bit more slanted forward. So this is going to be one of the closest related relatives to humans that we have in the primate order. So you've probably heard of Neanderthals. These are going to be members of the order primates that had heavy bones, thick brows, and protruding jaws. Their brains were about the same size as the brains of modern humans. So they had enough similarities that scientists early on actually thought that Neanderthals were humans, the same species. But it appears that they were just, closely related to us, and they had a lot of similarities, but they also had enough differences in their bone structure that lead us to believe that they were a different species entirely, and they have gone extinct. Now, they did exist for in the same time period as very early humans, so it appears that Neanderthals and humans did interact with each other. These organisms lived in caves and made stone scraper tools. So we find a lot of their markings and sort of like primitive artwork in caves that we find their fossils in. It tells us a lot about their society. For example, hunting was a huge thing for them because that's how they got their food. They didn't really have farming back when Neanderthals exist. So hunting was the big way of life. Every day or every couple days going out and hunting different types of organisms for food. Here's just a little comparison for what the average Neanderthal would look like compared to an average human. So on average, maybe a little bit shorter in height, their skull a little bit more flat up towards the top, but still a lot of similarities too between us. But like we said, Neanderthals are no longer exist. They have that group has gone extinct. Of course, Homo sapiens, that is the genus and species that we belong in. When we look at the earliest fossils of humans, we find them about 160,000 years ago in Africa. Those are the earliest fossils of humans and evidence of humans that we have. The first discovery of the earliest humans was in a Cro-Magnon cave in France. So sometimes you might hear ancient humans referred to as Cro-Magnons, but like I said, the earliest now that we have shows that they were in Africa. So it appears that that's where our species kind of originated, and then we migrated out of that continent, 160,000 years ago, and spread across the world, and to kind of live how we are now.